It seems like everywhere you turn these days, folks are buzzing about AI.
Yeah.
Like, how is it actually stacking up against us?
Mm-hmm.
I mean, our brains are still pretty amazing, right?
Oh, for sure.
So for this deep dive, we're going to tackle that very question. Neurons versus neural nets, who leads the future?
Yeah, it's a really fascinating comparison when you think about it.
Yeah.
We're basically talking about the building blocks of intelligence, both
Mm,
biological and the artificial kind.
yeah.
It kind of makes you ponder, like, the nature of thought itself,
Totally.
and of course the future of, well, technology, really.
Yeah, for sure.
Our goal today is to equip you with a really clear understanding of both biological neurons
Okay.
and artificial neural networks.
All right.
We'll look at what they have in common
Mm-hmm.
and also where they sort of fundamentally differ,
Got it.
and then we'll explore what role each might play in the years to come.
Sounds good. So why don't we kick things off with a closer look at those biological neurons, the OG spark of intelligence.
Yeah.
If you had to boil it down, what's the core function of a neuron?
Well, think of neurons like the messengers in your body.
Okay.
They're responsible for transmitting information throughout your brain and your entire nervous system.
Okay.
And this communication allows for everything from, something as simple as wiggling your toes
Right.
to something as complex as forming a new memory.
Wow. Okay. So what does one of these tiny messengers actually look like?
Right.
What are the key parts?
So every neuron has a central hub called the cell body.
Okay.
And extending from this are a bunch of these branch-like structures called dendrites.
Dendrites. Okay.
And you can kind of picture these dendrites as the receiving antennas of the neuron.
Okay.
They pick up signals from other neurons.
Got it.
And then there's the axon, which is like a longer projection coming off the cell body.
Okay.
And that acts as the transmission line, sending signals onwards to other neurons. So the points where these neurons connect, those are called synapses.
Okay.
And that's where those chemical messengers, the neurotransmitters, get released to transmit information.
I mean, it's mind-blowing when you think about how many of these tiny communicators we have packed in our skulls.
Oh, absolutely. The average human brain has something like 86 billion neurons.
86 billion. Wow.
Here's where it gets even more incredible. Each of those neurons can form thousands of connections with other neurons.
Oh, wow.
So you're talking about a network with trillions of potential pathways for information to travel.
Yeah.
It's a level of complexity that's just really hard to wrap your head around.
And this system isn't static,
Right.
right? Like, our brains can actually change and adapt over time.
That's exactly right. That's the magic of brain plasticity.
Oh,
It's
yeah.
this amazing ability the brain has to reorganize itself by forming new connections between neurons.
So that's how we learn new things.
Exactly. That's how we learn new things, adapt to new situations,
Right.
and even recover some functions after, say, an injury.
Okay.
It's like our brain reroutes those information pathways.
So cool.
Now, artificial systems, they're still really just trying to figure out how to do this effectively.
Interesting. So it's like we have a built-in advantage there.
In a way, yeah. And it's not just about adding new connections,
Okay.
Plasticity also involves pruning away connections that aren't being used.
Oh, so it's about efficiency too.
Exactly. It makes the whole system more efficient.
So that's the biological side of the equation.
Mhm.
Let's shift gears now and talk about their silicon counterparts. Neural networks.
Right?
What's the basic idea behind them?
So artificial neural networks, or ANNs for short,
Okay.
are algorithms that are, basically inspired by the structure of the brain.
Okay.
They have these interconnected nodes, which are often referred to as artificial neurons.
Artificial neurons.
And these are organized in layers.
Okay.
Information flows through these layers, and the network processes it step by step.
But how do they learn? They don't have experiences like we do, right?
Right. So the learning in ANNs happens by adjusting something called weights.
Okay.
And these weights represent the strength of the connection between those artificial neurons.
Okay.
So the network basically learns by tweaking these weights to get its output closer to the desired output,
Okay.
for a given input.
Mm-hmm.
And there are some key techniques involved here, like backpropagation and gradient descent.
Oh, yeah, I've heard those terms thrown around. What do they actually mean?
So backpropagation is basically the network looking back at its mistakes
Okay.
and then making small adjustments to the weights
Right.
to try and get closer to the right answer the next time.
Got it.
It's kind of like learning from trial and error in a way.
Makes sense.
And gradient descent That's like a hiker trying to find the lowest point in a valley
Okay.
by taking small steps downhill,
Right.
in the direction where the slope is steepest.
Interesting analogy.
Yeah, it helps to visualize it. And in this
Yeah.
case, the lowest point represents the lowest error.
Okay, so it's all about minimizing those errors.
Exactly. It's a process of gradual refinement based on the data it's been trained on.
And it seems like neural networks are powering so much of the tech we're seeing these days.
Oh, yeah.
Can you give some real-world examples of what kind of impact they're having?
Absolutely. A lot of the AI innovations you're probably familiar with are using neural networks under the hood.
Oh,
For example, ChatGPT.
Oh, yeah, everyone's talking about ChatGPT.
Right. So that uses something called a large language model,
Okay.
which is a type of neural network that can generate human-like text.
So that's how it's able to hold conversations and write stories and stuff.
Exactly.
Yeah.
And then you've got virtual assistants like Siri
Right.
that can understand your voice and respond to your questions.
Mm-hmm.
And that uses neural networks for speech recognition
Okay.
and image recognition software, the kind that identifies faces and objects in photos.
Yeah.
That's also powered by neural networks.
Got it.
And then you have self-driving cars that can perceive their surroundings and make decisions based on that input.
Right.
And that relies on neural networks for navigation.
Wow, it's everywhere.
It really is. Even sophisticated medical diagnostic tools, the ones that analyze medical scans to detect diseases,
Yeah.
those are increasingly using neural networks.
Yeah, the impact is just huge.
It is, and it's only growing.
Yeah.
One of the things they're particularly good at is finding those subtle patterns in huge data sets.
Oh, yeah?
The kind of patterns that we humans might miss.
Right.
So yeah, they're undeniably impressive,
Yeah.
but they're still very different from the human brain in a lot of ways.
Right. You mentioned that earlier. Let's dig into those core differences now.
Okay.
Where do biological neurons and artificial neural nets really diverge?
So I think one of the biggest differences lies in their structure and the sheer scale of their operation.
Okay.
Like we talked about, the human brain is unbelievably complex with billions of neurons and trillions of connections.
Right.
Even the most advanced artificial neural networks today are much simpler in comparison.
Okay.
They just operate on a much smaller scale.
So it's like comparing, I don't know, like a small town to a massive city.
Yeah, that's a good analogy in
Yeah.
terms of the number of connections and the level of interaction.
Right. And what about the way they learn?
Right.
You touched on that earlier, but can you expand on the nuances of their learning styles?
Sure. So biological neurons, they learn through this incredibly rich interplay of sensory experiences and emotional responses.
Okay.
And of course, constant interaction with the environment.
Right.
And this allows us to adapt to different contexts really effectively. We learn from relatively few examples
Okay.
and can often generalize those learnings to completely new situations.
Got it.
Neural networks, on the other hand, they typically require huge amounts of data,
Oh, wow.
like massive amounts of labeled data to learn even simple tasks. Yeah, they're really good at pattern recognition,
Okay.
but they can sometimes struggle to apply that learning to new situations,
Okay.
in the way that humans can do so intuitively. It's
Sure.
like, think about learning to ride a bike.
Okay.
A human, you fall a few times, you get the hang of it.
Yeah.
An AI might need to be trained on millions of simulated bike rides to achieve that same level of adaptability.
Wow, that's a huge difference.
Yeah, it is.
What about energy consumption?
Oh, right.
I always think of, powerful computers as needing a lot of energy.
And you're right. That's another major difference.
Okay.
The human brain is remarkably efficient when it comes to energy use.
Okay.
It only needs about 20 watts of power.
20 watts.
Yeah, which is about the same as a dim light bulb.
Wow.
And large neural networks, especially when they're being trained,
Okay.
they can consume megawatts of energy.
Megawatts.
Yeah, that's enough to power thousands of homes.
That's incredible. So there's a big environmental impact there too.
Yeah, for sure. The energy demands of AI are a serious consideration.
And how do they handle unexpected situations
Right.
compared to us?
So this is where human adaptability really stands out.
Okay.
We encounter new things all the time
Right.
and can usually figure out how to respond effectively without needing specific training for that exact scenario.
Right.
We can reason, we can draw analogies, apply our knowledge to new contexts. Neural networks, on the other hand, can be pretty brittle.
Okay.
If they encounter something very different from their training data,
Yeah.
their performance can drop off really quickly.
Got it.
Unless they are specifically fine-tuned for that new data.
So they lack that kind of common sense reasoning that we have.
In a way, yeah.
Okay.
And finally, there's consciousness.
Right.
It feels like there's just this massive gap between us and even the most advanced AI.
Definitely.
I mean, they can do amazing things.
Yeah.
Process information in incredible ways.
But they don't seem to have that inner world that we do.
Yeah, you're right.
Right.
They lack self-awareness,
Yeah.
Subjective experiences,
Right.
emotions.
Yeah.
And they don't have that kind of understanding of their own existence
Right.
like humans do.
It's a profound difference.
It really is.
I mean, it raises so many questions about what intelligence really is.
Yeah,
About what it means to be conscious.
absolutely.
So it seems like our brains have some pretty big advantages in some key areas.
yeah,
Adaptability, efficiency, consciousness.
right.
But neural networks have achieved some incredible things too. What are some of their main strengths?
So neural networks are really good at processing huge amounts of information,
Okay.
and they can do it incredibly quickly. They can analyze these massive data sets way faster than any human could.
Yeah.
They're also great at spotting patterns and correlations in data, even really subtle ones that we might miss.
Okay.
And that's led to some really cool breakthroughs. Like what?
Like in areas like fraud detection
Okay,
and scientific discovery.
got it. And we're seeing them take on more and more complex tasks, too.
Oh, yeah.
The kind of stuff that used to be thought of as exclusively human.
Right, exactly.
But like what kind of stuff?
Well, they're playing a bigger and bigger role in automation,
Okay.
taking on jobs that used to require, human intelligence.
Got it.
So things like writing computer code,
Okay.
composing music,
Interesting.
creating all sorts of content like articles and scripts.
Wow.
And another big advantage is their availability.
Right.
They can work 24/7,
Yeah.
no breaks, no
I
fatigue.
guess humans can't compete with that.
Right.
What about any specific examples of their capabilities?
Oh, there's a really great one, AlphaFold.
AlphaFold. Okay.
So that's an AI powered by neural networks,
Okay.
and it managed to solve this huge problem in biology,
Okay.
accurately predicting the 3D structure of proteins.
Proteins.
Yeah, from their amino acid sequences. Oh, wow.
Scientists have been trying to crack that for decades.
And this AI did it.
It did. And it has huge implications for drug discovery and, our understanding of life itself.
So AI is clearly crushing it in processing power
Yeah.
and pattern recognition.
Yeah.
But what are the unique strengths that we humans still hold on to?
I think one of the biggest ones is genuine creativity,
Okay.
particularly the kind that leads to truly new ideas,
Okay.
new inventions, new forms of artistic expression.
Right.
AI can mimic creativity to some extent, based on the patterns it's learned.
Okay.
But that spark of true originality, the ability to come up with something entirely new,
Right.
that still seems to be a human thing.
Got it. So it's like the difference between remixing existing songs and composing a whole new symphony.
Yeah, that's a great way to put it.
And what about those essential human qualities that guide our decisions and our interactions with each other?
Yeah, things like morality, empathy, and the ability to reason about ethics in a nuanced way.
Right.
Those are deeply ingrained in our human experience,
Yeah.
in our emotional intelligence.
Mm-hmm.
We can understand not just the facts, but the reasons behind them,
Okay.
the motivations, the emotional context.
Like we have this deeper understanding.
Exactly. We call that contextual intelligence.
Contextual intelligence. Okay.
And then, of course, there's our consciousness,
Right.
which allows us to reflect on ourselves,
Yeah.
to question our own perspectives, to change our actions
Right.
in a way that AI simply can't.
Makes sense.
And our brains have evolved over millions of years to deal with uncertainty,
Okay.
to understand complex social dynamics,
Right.
and to process emotions.
I mean, think about navigating a tricky social situation.
Yeah,
It takes more than just processing information.
absolutely.
You need empathy. You need to understand people's intentions.
Yeah.
So it seems like we're talking about two very different types of intelligence here,
Yeah,
each with its own set of strengths.
right.
So instead of thinking about it as a competition, like who's going to win,
Yeah,
maybe it's more about how they can work together.
right.
What does that look like in practice?
So this idea of hybrid intelligence,
Okay.
it envisions a future where the strengths of neural networks actually enhance our own abilities.
Okay.
You can imagine AI tools helping doctors make better diagnoses
Right.
by quickly analyzing tons of medical data,
Mm-hmm.
or artists collaborating with AI to create new forms of art,
Interesting.
or personalized education platforms that adapt to individual students.
That would be amazing.
It's about using the power of AI to amplify human intellect and creativity.
And what are those brain-machine interfaces that we're starting to hear about?
Oh, yeah, that's a whole other level.
Yeah.
So things like Neuralink.
Right.
It's a more direct merging of human and artificial intelligence. It's still very early days,
Okay.
but the potential is huge.
Yeah.
For restoring lost sensory functions,
Okay.
for treating neurological disorders,
Mm-hmm.
maybe even enhancing our cognitive abilities in the future.
I mean, that raises all sorts of ethical questions, too.
It does, for sure.
Hmm.
We need to be very careful as this technology develops.
It's not just about what we can do, but what we should do.
Exactly.
So it's not about one being better than the other.
No.
It's about finding how they can complement each other.
Yeah, that's the key takeaway.
So we need to understand the strengths of each
Right.
and use them strategically
Exactly.
to solve problems and create new opportunities.
Absolutely.
This has been a seriously mind-blowing deep dive.
Yeah, it really has.
I mean, it makes you appreciate how complex our brains are
Yeah.
and how fast AI is advancing.
It's incredible.
As these fields keep evolving, it's going to be so important to understand both of them,
Absolutely.
to know when to use which one.
For sure.
All right, well, that brings us to the end of this deep dive.
Okay.
But before we go, I want to leave you with one final thought.
Right?
So, artificial neural networks, they're learning and growing at an amazing pace,
Mm-hmm.
but the most intricate, the most adaptable.
Yeah.
And the only conscious neural network we know of is the one inside your own head.
Right.
I mean, it makes you wonder about all the potential we have.
It really does.
Thanks for joining us.
Thanks for having me.